Welcome back, everybody. The last video I did looking at all these merge functions made my imposter syndrome flare up a little bit. I just don't feel like I nailed it. Uh, I feel like I'm like 80% confident in what these do. But anyway, when you get imposter syndrome, one thing that you might want to do is to tackle something that you understand. So we've already looked at min and min by. So let's check out modify. And let's knock out the last three functions in the ends that we haven't looked at. Um, so let me clear my console and remove all that code. And let's look at this. So modify is an object function, and it takes an index. Then it takes a function that takes a value and returns a value, and then an object with a key value. So this v is going to be this v, and it's going to return a new v. And that's going to give us back an object with a key value pair. And so the index is the property, the key, the K in this object, or not necessarily something that potentially could be a prop in this object. So the property to be modified, right? And then a function to apply to the property. So we're going to take the value of that property and return a new value. And then the object to be transformed, so the data, and it's going to return an object, which is the transformed object. So that's simple enough. So what it does is it creates a copy of the past object by applying a function to the given prop. The function will not be invoked, and the object will not change if its corresponding property does not exist in the object. So that's interesting. It won't even invoke the thing. So it checks if the object exists, or sorry, if the property exists in the object first, and if it doesn't, it just returns. Um, it doesn't do anything. And then all non-primitive properties are copied to the new object by reference. So again, reference versus value. This is an object. All non-primitive properties um, are copied to the new array. How can you have a non-primitive property though? Like you can't have an array that's a property. Maybe they mean properties that have values that are not primitive. We'll see. Um, I think this example is pretty decent, so let's start with that one. Here's our data. This will be our object. It's yeah, I'll just do it like that. Name, James, age 20, pets, it's dog and cat, an array. So like this is not a primitive. This is an object, and it's saying this will be passed by reference, I think. So let's keep that in mind. And then so I'm gonna step through this. So we do r.modify. Oop, r.modify. And we're going to take the first object, which is going to be the index. So we need a key that we're going to modify. In this example, they're using age. So let's do that. So that's the 8 that we're looking for. And it's a string, right? So and it reads very naturally. Like we're going to modify the age. How are we going to modify it? We're going to increment it. I think there's an inc function, right? They use it add one, but that's the same as inc. So we're going to take the age property, we're going to increment the value of the person object. And then we should get name James, age 21, pets, dog and cat. So save that and run it. Name James, age 21, because we incremented the age. And the pets is dog and cat. And then they have another example where they modify the pets property, and we append the string of turtle, but we're gonna append a taco to the person object. So yeah, it reads very naturally. Name James, age 20, pets, dog, cat, and then we have a pet taco. Um, so no mysteries there, except for that all non-primitive properties are copied to the object by reference. Um, so let's log out the person object after we've logged out the other one, and there should be the different, yeah, like there's the first one with the taco, there's the original object, but it's saying non-primitives are copied by reference, but this is immutable. Yeah, I'm not exactly sure what that little part of it means because all of these functions return a new object, or all random functions are immutable. That's what I'm trying to say. Um, so dog, cat, taco, dog and cat did not mutate it. All primitive properties are copied to the new object by reference. Okay, so they are copied, they're not mutated. Maybe that doesn't really matter. I mean, they wrote it, so there might be some sort of case, but I'm not sure what it is. So I'm not going to worry about it too much. I find this to be pretty useful, though. Uh, this lets us modify an object, but it's really clear how we're modifying it. Like we're modifying the person, the pet's in the person, and we're modifying it using this function. Yeah, pretty straightforward to me. Let's look at the modify path, which is similar, added at the same time in version 28, 0.28. The only difference in the type signature is that the index is an array. And I remember there's another one with path. Um, just take a quick look. Let's just use our filter here. Yeah, associate path and disassociate path. No, I didn't look at those. Those were not functions that I looked at. It was has path. That's what it was. Has path takes an array of indexes too, and it just tells us, is there a property on an object, but you give it the path of where to look. So first go to A, and then nested in A is a B, and does that path exist? And so not property is just wanting to know if the path exists. So this is to determine the shape of an object, essentially, versus has. Uh, well, that has own property. Okay, maybe that's not what I looked at. That's okay, but the same thing. With the path, you give it an array of indexes to determine the path. So this creates a shallow clone of the past object by applying a function to the value at the given path. I would assume this is a shallow object as well, but they're specifically stating that here. The function will not be invoked and the object will not change if its corresponding path does not exist in the object. Same thing. So it checks if the prop is in the object first. And then all non-proper primitive properties are copied to the new object by reference, same as above. Get rid of that. And let's do modify path. Yeah, and then let's use this new person object where there's nothing nested here in the last person object we use. But this one has a name of James and an address, which is a nested object with a zip code of 90210, because I'm a child of the 80s. Um, and so here, instead of saying, we can't just say zip code because that's not one of the root properties. It's nested under address. So first we would do, well, an array, and then we would say, go get the address, and then inside the address, go get the zip code, and then append a taco to the end of the zip code. And that gives us new object with name James, address, zip code 90210, taco. And we're appending. So let's concatenate. I get name, address, zip code. And we're concatenating the taco. So actually I wanted to do it like this. Somebody's knocking. Let me peek out my window. Pardon me. It's like the cat in the original series. Okay, I'm back. It was a phantom knock. So r.flip, let's see if that did what I want. I wanted to do 90210 taco. And that gave me an uh, error. Oh, what am I doing? I would need to flip the concat, and that gives me what I want. Yeah, so very similar. It's just if you have nested objects and you want to modify that, you give it the path of where to get to the object, and then do the same thing you did up here. So again, both pretty cool and useful functions. And then the last one in the EMs, so we've looked at modulo, and surely, yeah, we've looked at multiply. This one's straightforward. Take two numbers and multiply them together. It doesn't matter um, what order you pass the numbers because multiplication doesn't matter. Division does. Um, and we've looked at divide. And that's when we looked at multiply. Divide was in the first series that Christopher did. And of course, you might need to flip it if you want to partially apply, like you're doing here. But anyway, we're going to look at move. And move is a list function. And so this is cool. And this is kind of a pain to do without a function like this. It takes two numbers as the first two arguments, and then a list of A's, and it returns a new list of A's. So number is the source index. So they probably should have said this is an index, but of course the index in an array is a number. And this is the two. So it's kind of like slice or splice in that regard. And this is the list which will serve to realize the move. That's a funny way of saying the list. And it returns a new list that's reordered. And so that's what this does. This is when you want to take a list and reorder it. Let's take use our sum data here and use d.list, which looks like this, an array of 1, 2, 3, 4, 5. And let's move the 2 somewhere else. That's basically what we're doing with this function. So we're going to say r.move. Again, it reads kind of naturally. So the first is the from. So if we want the two, that's at index one. That's what this first argument is. And if we want to move it um, like here, when we take the two, this is going to be index zero. This is going to be index one because we're going to move the two. This will be index two. So that's where we want to move it, is to where index two is, I think. I could be off by one. It's very common. And then the third thing is the list that we want to act on. What did they say? The list which will serve to realize the move. Uh, list. So this is our original array. Okay, I was off by one. So we would want to do it three. Let's log the list as well. There's a first list, one, two, three, four, five, and then we take the item at number one at index one, which is the two, and we move it to index three. So now that was index zero. This is index after being modified zero, and then one, and then two, and then we want it to be three. Yeah. So that's why we do three. So you get one, three, four, two, five. Pretty cool, right? I mean, you know how much of a pain that is to do? We got to try it now. If we were just using built-in things, we could say a new list where we want to spread the d dot list dot slice starting from one, because we're moving the two. And that's the second, or that's the index one. To start there, and then we would want to go to, I always forget the second one, the end. It's like one before or that one. So we'll just try it with three. And we need three dots here. Let's just see what that gives us. So what I'm hoping that would be like give us oh no, we want to start at zero, and we would want to go to right before it. So we just want to take one item, see what that gives us. I'm thinking that's going to just give me one. Yeah, and it gives me one. And then we would want to add another thing to our new array and spread. Oh, wait, though. That just gives us one, but we can't just take the rest of the list because we want to move this here. Oh, well, we could take, let's see, we could take g.list. First of all, we're going to need some lines here. Going to get long. Okay, take that d.list, and then we need to slice from two, starting with three. We put it after the four, so we would want to take two. Let's just step through it. I don't think I saved. Sorry. I did save. I just do to the end. Yeah, that worked. If I pass it the second argument, I'm saying start at 0, 1, 2. So start at 3. I just want the 2. Like did I not save before? No, I didn't. Or I mean, yes, I did. That's interesting. Yeah, slice isn't the best way to do this, or I'm doing it wrong, right? Because oh, it's saying the end. I was thinking this meant like how many to take. Yeah, okay. So I'm going to pick up the 2 and move it after the 4. So I would want to take the 2, which starts at 1, and would I do 0 or 1 there? I can't remember. I feel like I'm not saving. Yeah, maybe I need to take 1. No, that's not it either. I was thinking I'm picking up the 2 and going one place. Hmm. Unless I need to tell it. Yeah, that was right. 1, 3, 4, 2. But then I would need the last item too. And this is a mess, right? So this move thing is really handy. Otherwise, like maybe I should be using splice, but splice is a um, mutating thing, a mutating function or method, really. There's a 2 sliced, right? This is new and it may not be available in Ramda. I mean, in Node. First, I need the. Wait, what was I doing before? Yeah, that's right. All right. And then we'll use the 2 splice. Yeah, that's not available here. So again, I mean, I couldn't figure out the slice that first time. Maybe you could. Um, and the way I was creating that, like I had to look at the array and it was going to work for other arrays. It was too specific to that case. I might as well just type the new array by hand. Yeah, so move allows us to do this very easily. Let me just go back and demonstrate how much easier that was. If we took our move function and then you tell it where to start, we start at 1 and we move it to, was it 3? And then we give it our list, t.list, save it, clear this, and then we move the 2 from here to after 4. Get 1, 3, 4, 2, 5. Yeah, very, very handy. Very handy. Oh, and you can do it. Let's say we wanted to move the 5 to the beginning. You can do negative. So start at the end and put it at the beginning. We should get 5, 1, 2, 3, 4. We get 5, 1, 2, 3, 4. Yeah, very cool. And then it doesn't mutate. So I will never use splice again, I don't think, if I'm using Ramda. Or there is a 2 spliced. I'm almost sure about it, but it must just be, it's so new. It's probably only in Chrome or at least just in browsers. Um, we're done with the M's though. We're gonna pick up in with the N's, just scan and see how many there are. Not too many, and I feel like we've covered a lot of these. Once again, thank you for spending your time with me. Tell a friend, and I'll see you in the next video.